Hey everyone, welcome to the channel. In this video, I'm going to take you through a really exciting NLP project that is text classification using DistilBERT. Before we dive in, I'm Shubham Trashya, currently pursuing my BTech degree from CV Raman Global University. I would like to thank CV Raman Global University for supporting this initiative as part of our AI ML coursework. Also, a big shout out to Cranes Varsity for providing us with top notch training in artificial intelligence and data science. Their mentorship made a huge difference in bringing this project to life. Let's jump right in. Introduction to text classification. Text classification assigns predefined category to textual data. It powers applications like sentiment analysis, spam detection, and topic categorization. Traditional methods include naive-Bayes, SVM, and logistic regression. These are the traditional methods. However, they struggle with context and scalability challenges. These are the issues faced by these traditional methods. Overview of BERT. Before dive into overview, the BERT stands for bidirectional encoder representation from transformers. Here are the architecture and training. Here are the features and variants. Architecture and training are transformer are attention mechanism. Pretend on masked language modeling. Next sentence prediction. Features and variants like contextual embedding, BERT pairs, BERT lab, specialized models trained on Wikipedia and Vox corpus. Introducing DistilBERT, a lightweight BERT. Knowledge distillation, architecture, and efficiency gains is a part of BERT, is a type of BERT which is very smooth, faster. I'll explain that in the next. DistilBERT training methodology. Knowledge distillation minimizes difference between teachers and student outputs. The minimum difference would be the part of training methodologies of Distil. Combine cross entropy, cosine embedding, and MSC losses. Training details uses Wikipedia and Vox corpus trained on 1632 GPUs for days. Advantages of using DistilBERT. As I said, it's a speed, it's small memory footprints for deployment, efficiencies, lower compute cost in training and use cases ideal for mobile and edge computing. Implementation, setting up the environment, as we need libraries like transformers, pytorch, tensorflow. I've used transformers, tensorflow in my example, which you're gonna see in the end of the video, at the end part of the video. Now, a dataset like AMDB, movie reviews, sentiment 140, you can use this type of datasets. I have taken a dataset of text classification, but you can use this for your project also. Preprocessing like tokenization and input formatting, hardware like 8 GB plus GPU. That one is a recommended one. Like fine tuning DistilBERT for text classification. These are the step of the text classification like text task layer. Here we will get the task like attach classification layer on DistilBERT. Okay, then hyperparameter like tune learning rate, batch size, epochs. What is epochs? Epochs means it's a number of time that device will run that code to get the more accurate output. Okay, so training loop, it's a forward pass, loss calc means calculation, backprop, optimize, evaluation. We will get the accuracy, precision, recall, and F1 score. Practical application and examples. Few practical applications are there and examples also. I have taken examples of text classification. I will show you it after this. Feedback analysis. Okay, automate sentiment in customer reviews. New categorization like classify news by topic efficiently. Social media monitoring means filter harmful content and track trends. Example uses detect sentiment in tweets about product launches. Now I will show my example. Please check it out. I've done that in a VS Code. I will explain in that part also. Okay. So here is my example. My example is text classification using DistilBERT model. You can use this code in Collab. To be honest, I'm a Collab user. But for GitHub links and other thing, I have used VS Code, and VS Code is a very good compiler. So now this is my code. Here, I will explain my code now. In the beginning, I have imported all the required things like import pandas as PD and import from transformers, import DistilBERT tokenize first. Okay. Then from sklearn model selection, import test test trend test plate. In this trend test plate, we will do the training part. Now load the Excel file. We've got an data set. We have two data sets. I have marked my code and my data set in my GitHub account, and I will provide the link of my GitHub account in my channel in my video in the description box. You can check it out. Now it's a DF. Here we'll data frame a PD, read Excel. Like here I'm introducing the data set here. I've given a data set which is output data set, and I have defined the column as label and text. Okay. In this print head, it will print off 5 rows of the head and text. As type of string, here I have introduced the data types of it. Text is a string, and here is a list is a list labels. Then here is the training process. Train text, val text, training labs, val labs as a training test split. Here it will work on 80-20%, means 80% training and 20% testing. Okay. Then we have done the tokenize, training encoding and val encoding. Then import touch from touch utilities data, import datasets and data load, class and text data types. Here I have defined 3 functions like init, get item and len. Train datasets is text dataset, which is an x-axis and y-axis, train encoding and y, and is train labels. And same as that, val dataset is text dataset, which is val encoding is x-axis and val labels are y-axis. Now I've given my code. You can check it out in my GitHub account. It's Subham454. I will provide the link also in the description box. So don't worry. Yeah, the from transformers, as I said, we will use transformer dataset also, isn't it? So we have used DistilBERT for sequence classification, Torch Optim, and TQDM import TQDM. Okay. Then we have to check the device, load the model in it, optimize it, then training loop. Here I have told you now epoch 3. Epoch 3 means it will run the code thrice to get the most accurate answer. Most accurate answer. Okay. After that, it will epoch 1, epoch 2, epoch 3, 100% run. Then we will go to the X sklearn matrix classification report and accuracy score to get the accuracy, precision, and F1 score. Okay, we've done each and everything. Here we got the accuracy of 89% and model safe predict pre-trained DistilBERT model. Tokenize same pretended DistilBERT model. Okay. Load test data using pandas Excel reader. Here we will again load test data. It is another data set. I have mentioned that, and uh, I I have put the link in the my GitHub link also. So now print test df head means it will print the top five rows of the here are the top five rows. Then dataset class for test. You have defined again the same thing done for the test datasets also. Now model evaluation will be done and true test labels with torch no grid for batch in test loader. We have done the stuffs. Okay, then the accuracy will be 88.46. In web situation it was 89 and here it is 88.4%. Means we are getting the most accurate. Okay, then we have defined and predicted test. We have tokenized the data. We have predicted that as sentiment as positive if predicted class is 1 or else negative. We have used here if else. Then example is positive. Predicted what? The movie was absolutely amazing. I love it. Example is predicted. The movie was incredibly boring and a complete waste of time. Text. This movie was absolutely amazing. I loved it. It's a predator is a positive. And if a negative, then it will show as the movie was incredibly boring and complete waste of time. As we used to judge. Then here is the model, and I have given my app.py in my GitHub account. You can check it out that also. So it's a job leave, create a directory to self model. Model directory is self model, and we have done the model path web. Okay, this is the example. So this is my example. You can try your own code also. You can take any of topic and do this. Now let's conclude this video. So here is the conclusion summary. DistilBERT balance accuracy and efficiency effectively. Future direction is optimize further for broader NLP task. Call to action like explore DistilBERT for your text classification project. Okay, so thank you. Have a nice day.